For 4.3, we're going to be finding the area of trapezoids, and your key purpose to keep in mind as you work today is that you can derive or come up with, again, the formula for finding the area of a trapezoid using what you know about triangles and quadrilaterals, because as we demonstrated in our activity, you can take trapezoids and kind of split them apart like we have done with some of our other polygons, and you can get a clear-cut triangle and quadrilateral, and you can use that information to help you figure out your area formula. The actual formula we're going to use tells us that the area of a trapezoid is 1/2 the product, which of course by now we know means multiplication, of its height, and we usually use h to represent that, and the sum, and I did notice that some of you were having some trouble with that word sum, so we do need to keep in mind that it means addition of its bases. And because a trapezoid has two bases that are different lengths, we usually use B to represent base, but then we put a little, what we call a subscript number down at the bottom, so we would call it base 1 and then base 2. And what that formula ends up looking like is area of a trapezoid is equal to 1/2 times its base still, but again we've got two bases in a trapezoid, base 1 plus base 2, because we did say up here sum of those bases, and then times the height, which there will only be one height on that trapezoid. So if you had a trapezoid that looked something like this, we would have one pair of parallel lines here, which would be considered your bases, but they're different lengths, so you might label one of those base 1, the other one base 2, and it doesn't matter which one is which. And then you would go in and you would find a height just like we did on parallelograms that would have to create a 90-degree angle, and then you would label that as your height, and then you could literally just fill in all of the parts to your formula. For example 1, we're going to be finding the area of trapezoids, and specifically we're going to use this trapezoid to get us started. And so we're going to write the formula out just like we have been on everything else, and it does look a little bit longer, so it's area equals 1/2 base 1 plus base 2, and again we'll figure out which is which here in a minute, times the height. And the one you're going to want to remember not to forget about is that height, because once you get done adding things you don't want to forget to multiply by that height. So just to be fair, early on you do have the option, if you're concerned about forgetting that, to put that at the beginning of your multiplication, to do 1/2 times the height times the two bases added together, because we know that our properties tell us that when you're multiplying you can switch the order of things, and since this is all together in parentheses we can switch that and we'll still get our same answer, since the commutative property tells us we can move some stuff around. Either one is completely fine. As we go to fill in here, we're going to keep that 1/2 and we're going to start to fill in our bases and our height. And in this case, again, it doesn't really matter which is your base 1 or which is your base 2, so you just kind of pick one to be the first base and the second base, and you add them together. So in this case it'll be 5 plus 9 times the height, and in this particular trapezoid you don't have to draw a height in, because this one goes corner to corner and it already has a right angle. So you can go ahead and just use that as your height and fill it in here, and then you would just go through and do 1/2 times 5 plus 9, which is 14, times 6. And just like we did with triangles, you can do a couple of things. You can take half of the base, half of the height, or you can multiply those two together and take half of the whole product, whatever makes it easier. I'm going to go ahead and just take half of the base right now, so that's 7 times 6, and then I ran out of room, so I'm going to move that up just a little bit, and then half of 7 times, or excuse me, we took half of that already, so we'll just do 7 times 6, which is 42. And our area still continues to have a square label, so this one was feet squared, or square feet would be fine too. So 42 square feet is the area of this particular trapezoid. For letter B, we have a different trapezoid, and we continue to put the formula first here, 1/2 times the first base plus the second base, and multiply that by the height. And so when we go to fill in, we have 1/2 times the sum of the first base here, which again you can pick either to be base 1, but I'll put in 8.5, and then base 2 will make 11.5, and it doesn't matter at all if you switch those, because the commutative property tells us even with addition we can switch the order and we'll still get the same answer. And then we're going to multiply that times the height, which in this case again is drawn in, and it does go from one corner or vertex down straight down to one of the bases, and we know it makes a right angle, so this one must be our height. So times 5, and this one of course does have decimals in it, but that doesn't necessarily make it any harder, it just means you have to remember what to do with them. So we're not going to touch the 1/2 right now, so we're going to leave that there. And then do side math, whatever you need to do to make sure you line up decimals and add those two numbers together. Those are your bases. And then when you do that in addition, remember to just drop your decimal down. It does say 20.0, but since we know that's the same thing as the whole number 20, we can just put that in there. And then times 5. And now we can go ahead and take half of 20, which is 10, times 5. So we know that's 50, and since this one is labeled in meters, it would be square meters, or meters squared. And so our final area is 50 meters squared. For example 2, we're going to find the area of a trapezoid on a grid, but we're not going to do the estimating inside like we did with some of the other grids. We're literally going to use it to just count base and height and things like that. And in this case we do have a multiple choice version, so we'll see if our answer matches up to one of these. The first thing we're going to have to be able to do is we're going to have to find bases and height. And again, we have had the conversation several times that we're kind of used to looking for bases on top and bottom, but that's not always going to be the case. Here, we're going to probably have to use the sides to be our bases because these are on a diagonal. So as we've said before, it's a little hard to get an accurate count here, but we can go ahead and imagine this on its side. And so we could use this side here as base 1 and the other side over here as base 2. And then to find the height, we would just pick either of these corners and then go straight on one of these lines till it gets to the other corner. And as long as it forms a 90-degree angle, then we can label that one as our height. And we can go through and just then count how many are in each spot. So this base has 2 boxes, so base 1 would be equal to, whoops, put it on pen function there, would be equal to 2 units. And then this one over here, base 2, that's only 1 box, so that would be 1 unit. And then for the height, we count across number of boxes, and again, it's on a straight line now because we cut from one corner down to the base and it made a 90-degree angle. So we've got 1, 2, 3, 4, 5, 6 boxes all the way across, so our height would be equal to 6. So when we go to fill in our formula, area equals 1/2 times base 1 plus base 2 times the height. So we'll fill in our bases here. One of them, base 1, we said could be 2 units plus base 2, which was just 1 unit, times our height, which was 6. And then when we go through and do the actual the evaluating part, 2 plus 1 is 3 times 6. And again, we've said before, you can take half of either of these, or you could do multiplication of 3 times 6, which is 18, and then take half. I'm going to do that this time just so that I can avoid having to do half of 3 and get into decimals. So 1/2 of 18 is equal to 9, and since we don't have an actual labeled unit, we would just say units squared, and then we're going to check, and that does match one of our answers. So we would say that it would be C, the area of the trapezoid, would be equal to 9 units squared.